All right, guys, welcome back. We are going to be going over Chapter 13, Section 1 or 13.1, which covers sample space and the fundamental counting principle. Chapter 13 in and of itself is all about probability and the probability type questions that you've probably heard of before, like what's the probability of pulling 2 red balls out of a bag with, 5 blue balls and 5 red balls, something like that. Is going to be done later as we move on. So in 13.2, we'll talk about that as well as stuff in 13.5 and 13.6. But right now we're just going to cover sample space and the fundamental counting principle to kind of give us a backbone to work with. So the first thing we're going to talk about is sample space. And a sample space is the set of all possible outcomes of an experiment. The set of all possible outcomes of an experiment. So if I have an experiment with flipping a coin is flipped twice. Represent the sample set for this experiment by making an organized list, table, and diagram tree. So I'm going to model all 3 of the different ways that you can show a sample set. One thing you have to think about, what are the possible outcomes when you flip a coin? So you flip a coin, it has 2 sides. One side is heads. I'm going to use an H to represent that, and one side is tails. And I'm going to use a T. So there's a couple of different ways we can do this. So if I'm doing an organized list, I'm going to list both results next to each other. So if I flip a coin and I get heads, if I flip it again, I could get heads. So that's one set of options. Or I could get heads and then tails. Or I could get tails and then heads. Or I could get tails twice in a row. So that's an organized list. And I'm just using some sort of key as far as instead of having to write heads, heads, tails, tails, or heads, tails, I'm using an abbreviation or a variable to represent the possible outcomes. Now for a tree diagram, I'm going to start off with my first flip. And that first flip has the option of going heads or tails. And then from there is my second flip, which you don't need to write the second flip. I'm just putting it there so that you realize. So from that first heads, I can go heads again or tails. And from that first tails, I could go heads or tails. So this is a tree diagram showing my outcomes. And then the last one is a table. And this is going to be similar to like a Punnett square, if you remember from biology, or box method. So I'm going to create a table. I have tails and heads and tails and heads. So the first line is flip 1. And the second line is flip 2. I'm going to write that someplace else. Flip 2. The possibilities for flip 2 and the possibilities for flip 1. So I follow just like I would doing the box method with multiplying polynomials. Excuse me. Or doing Punnett squares. So tails, 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 heads, heads, tails, or heads, heads. So these are all different ways that you can use to show the sample space. So different questions, I might ask for a specific representation, and sometimes I might let you choose. So you can then pick which of these you feel most comfortable with. So I'm going to look at a few examples. This first one says, create a tree diagram representing a sample space. So it has to be a tree diagram. Maurice packs suits, shirts, and ties that can be mixed and matched using the packing list below. Make a tree diagram to represent the sample space for business suit combinations. So the first thing I like to do is I'm going to go through and give each item, like gray suits, black suits, khaki suits, a different letter to represent them. So for my gray suit, I'm going to use a G. For black suit, I'm going to use a capital B. For khaki, I'm going to use a K. And then I'm going to change colors. For shirts, I've got white. I can use a W. And I have a light blue. Since I already used a B for black, I'm going to use an L for light blue. And then for ties, I have the option of a striped tie or no tie. So I don't even have to wear a tie if I don't want to. So I'm just going to say tie or no tie. So I'm going to start this at the top with my suits. And that suits can branch off in 3 different directions. I can go my gray suit, my black suit, and my khaki suit. From there, I can branch off into my different shirts. So I have a white shirt and a light blue shirt for my gray suit, a white shirt and a light blue shirt for my black suit, and a white shirt and a light blue shirt for my khaki suit. Now we're not obviously going by what actually looks good together, we're just giving him all the options. Maurice can make those decisions on what actually looks good together when he puts it all together. And then I have to decide tie or no tie with each shirt. So with my gray suit, with the white shirt, he can go tie or no tie. With the light blue shirt, tie, no tie. The black suit with the black suit with the white shirt, tie, no tie. Black suit, light blue shirt, tie, no tie. Y'all are catching the drift here. Everything is going to have the same branched off possibilities. Now I want you to count how many total suit combinations there are. And the way you're going to do that is count the very last letter. So T, N, T, N, T, N, T, N, T, N, T, N. We're just counting those. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 different suit possibilities with this situation. Wow, that's a lot. That's crazy, guys. All right, let's look at 2 more quick examples, and then you can work on a few questions that are similar to this. All right, so the MHS baseball team can wear red or white shirts with red or white pants. Let's make a table to represent the sample space. So we're going to put pants on top, and their options are red and white. And then across the side, I'm going to do shirts. And again, red and white. So red, red, white shirt, red pants, red shirt, white pants, white on white. So they have a total of 1, 2, 3, 4 possible outcomes. Can't spell. There we go. 4 possible outcomes. All right. And then the dance club is going to go see either Sleeping Beauty or the Nutcracker. And they have 2 options to go see these. They can either go to Symphony Hall or the Center for the Arts. So we're going to make an organized list. So the first thing I do is I make a key. So SB for Sleeping Beauty. N for Nutcracker. And really, we can make this 1 letter. We can just do S. That might be easier. And then for the Symphony Hall, I'll use H for hall, since we are already using S. And then we have C for the Center of the Arts. So that's the first pick. That's the second pick. So we have pick 1, pick 2. So we can pick Sleeping Beauty and go see that at the hall. Or I can pick Sleeping Beauty and see it at the center. And then I could pick the Nutcracker and see that at Symphony Hall. Or I could see the Nutcracker at the center. So I have 4 possible outcomes this way. It's kind of confusing when they've got really long names, but as long as you pick a letter or something to represent it, you should be all right.